Hello everybody, Fáilte for Ash. Thank you very much for being with me this morning and taking the time out of your day. If you've just joined me, that's great. If you're with us from the earlier session, that's also great. We're going to start with the topic now on calculus. But before I do, I just thought I'd maybe mention a little bit about where you might find the resources for today's sessions. I'm Tomás Dr. Tomás McGuckagan, the Director of Academic Programs in Griffith College, and I'm coming to you live, obviously, from Griffith College today, rather than in person. You're not visiting the campus. Just behind me in my screenshot there, that's actually a picture of the colleges, or some of the colleges' student accommodation where our students live throughout the year. I'm going to just show you briefly, if I can. I'm going to share my screen with you, I think, and I'm going to try and show you just my screen, I suppose, and on that I'm going to show you, if I can, the Griffith College site. This is the website griffith.ie, www.griffith.ie, and this brings you into the college's site. If you go down there today, scrolling down, you'll see Free Leaving Cert Maths Revision. And if you look at Maths Resources there, click on it, it'll tell you more about the courses, about how we prepare them and the supports available, the various videos and the tutorials that are there. Asperla agus ascrailge tá right beag ascrailge come on. And if you look at View Resources, you view resources here, you can come down to Leaving Certificate Ordinary Level Maths Thursday Revision Booklet available here. So if you click on that button there, it'll show you the notes that I have for today. Well, that's a booklet you can print from start to finish, and they're the notes that we went through in the earlier session on the functions and graphs. So you can just save that as a PDF or print it in whatever form you want at home, or have it on your laptop or your phone or whatever you want. But if you do want to write on it, it's sometimes handy to print out those notes as you can. So I'm going to go on from the functions and graphs, and I'm going to start on the next section now, which is calculus. The notes we did on equations and inequalities are there as well. So I'm going to close that. I think I'm going to stop sharing for the moment, and I'm going to come back and I'm going to start this session on calculus. And before I do start about calculus, I mean, people say, why do you learn calculus at all? Why is it on the Leaving Certificate, and why would anybody be interested in it? But calculus is a really, really important part of mathematics, and it really makes the world work for us in many ways. In the functions and graphs there, we talked about the minimum point, finding the minimum point with dy dx, or the maximum point with dy dx. Think of all the times you want to find the best, the worst, the least, the most expensive, the least expensive, the most profitable. Anytime people want to talk about most or least, generally it means there's a rate of change there. I say, what's the most beneficial or the best way or whatever? And very often behind that, that's calculus. So that's why calculus is there. The best speed, the best return, the best whatever. The differential return on a particular investment, whether it's finance, whether it's engineering, calculus is used all the time. So that's why we need it. But think about it. Anytime you hear yourself using the best, the most, the least, the worst, very often if it's talking about a function of something in life, economics, or anything to do with a physical structure, the highest point or whatever, or the highest speed, there's calculus there. So that's why it's on your course, and that's why it's considered important, not just for the Leaving Cert, but for life. So I'm going to start now by sharing my screen. Again, I'm going to go, and hopefully you'll be able to see my notes, and hopefully you've access to them as well. So we're going to look at calculus, differentiation, and rules. So when we start in calculus, I'm going to imagine that what you're going to build up on this topic and on other topics, it's a set of tools or a set of tricks. So if you imagine an electrician coming into your house, he or she would have a box of tools. They might have phase testers, they might have electrical cables and all of that. If it was a plumber, they may have different equipment there for spanners and wrenches for taps and all that stuff as well, pressure points and all that for measuring flows and stuff. So you're going to have your set of tools for calculating the answers to calculus questions as well. So we're going to go through those. That's a set of tools that you'll bring with you. They're pages that I'll highlight. You might want to highlight them with a highlighter marker or something. And you say, they're the ones I'm always going to bring into the exam with me. Well, they're in the log tables anyway, but they're the ones I refer to all the time. So I'm going to start with calculus, and we're going to do some differentiation rules. This is your set of tools. This is your toolbox, and we'll be coming back to this again and again. So basically it says when you differentiate f of x, sometimes that's written as y is equal to x to the power of n, then f dash x, or dy dx, is equal to n times x to the n minus 1. So whatever the power here was, you take it down and you reduce it by 1. So you take it down to be a multiplier and you reduce it by 1. So fx is x to the n, and f dash x is nx to the n minus 1. So if we were to take examples of that and say y is equal to x squared, dy dx would be 2x. We would take down the 2 and reduce it by 1. If it was y is equal to x to the 17, we would say dy dx is 17 times x to the 17 minus 1, or 17 times x to the 16. Now we're not likely to get x to the 17, but I'm just showing that the rule works. You just take down the number and you reduce it by 1. There's another rule here that says when f of x or y is equal to uv, or multiplying two things together, then dy dx is u times dv dx plus v times du dx. So we'll deal with that when we see it, okay, in all the examples that follow. There's another rule here that says quotient rule. When f of x is written as something over something else, u over v, then the formula you use is this. And equally, there's a way sometimes of using a chain rule. I'll show where that might be useful. You don't have to do this one, but it's a way of sometimes being able to short circuit a question that makes it relatively straightforward. And I'll give one example of that as well. But again, you can generally solve that by one of the other two ways, or it's just a bit longer. That's all. So I'm going to say that I have a set of tools. I won't go through them yet, but I'm going to keep them. I'm going to keep these safe because whenever I get a question, I'm going to say, does this fit one of the rules? And when it does, I will use it. So I'm going to keep this safe somewhere over here. Just from a terminology point of view, when we say f of x, we can also mean y. Y is f of x, and dy dx is f dash x. So that's how that works. Or f double dash x, if you were doing it twice, would be d2y dx squared. So that's just the language we use. So here's our first example. Differentiate, that means find dy dx, or find f dash x. 3x cubed minus 7x squared plus 4x plus 7. Now, I'm going to just take the first bit first. I'm going to leave out all of the other stuff later because that's just really another sum. I could say y is equal to minus 7x squared, or y is equal to 4x, but I'm just going to take the first bit. And I say, how do I do that? Well, I have a formula here that says if y is equal to x to the power of n, then I just take down the n and reduce it by 1. That's all I do. Okay, so I have a number here, but that's just a multiplier. But it says y is equal to x to the 3. That's sort of like the differentiation one here. Yeah, that sounds good. So I'm going to take down the 3. So dy dx, I'm going to take down the 3 and going to call that 3x squared. But because I had 3 of them, I'm going to put another 3 there. So 3 times 3 is 9x squared. So that's dy dx of that bit. What about y is equal to minus 7x squared? Again, I say, yeah, that sort of fits this pattern again. There's an x to the power of something. So in this case, it's x to the power of minus, or x to the power of 2. So I'm going to leave the minus 7 for the moment, and I'm going to say dy dx is equal to 2x. But this was multiplying by minus 7, so I'm going to have to multiply this by minus 7. And minus 7 by 2 is minus 14x. So that's dy dx, is that. So if I were to join the two together and say y is equal to 3x cubed minus 7x squared, my dy dx would be 9x squared minus 14x. But the question's a bit longer than that. I've got 4x and 7, so it's 3x cubed minus 7x squared plus 4x plus 7. So dy dx is, I take down the 3, so that gave me the 3 times by 3 is 9x reduced by 1. The 2 became 2x by 7, which was 14. X. Now, x on its own. Well, if it's x on its own, it's really just x to the power of 1. And that would be 1 times x to the 1 minus 1, or 1 times x to the 0, which is 1. Really, that's the full answer of it. But really, if it's just determine x on its own, we just get rid of the x bit and we take down the 4. And the last bit, if we differentiate 7, 7 doesn't change. 7 is always 7. It doesn't change with the next value. 7 is 7. So dy dx of that is 0. So this is the full workings of it. If we were to do it, we take down the 3 and reduce by 1, take down the 2 and reduce by 1, take down the 1 and reduce by 1, and take down the 0. And if you take down 0 and multiply it by something, it goes to 0. So ultimately what I got was 9x squared minus 14x plus 4. Exactly what I got here. So I just split each of them. I took one at a time. That's a sum, that's a sum, that's a sum, and added them all together. So that's f dash x, and that's an example of an exam question you can be asked. That's standard. That's one of the things they'd ask you to do. Now, let's look at the next question. The next question is reasonably similar. It says y is equal to x cubed plus 2x squared plus 3x to the minus 2. Now, this is a number on the top. We look up here and we says, it's just a number n, it doesn't matter, it can be just any number, so minus 2 is fine. So it's no different to anything else. The x cubed, I take down the 3 and I get 3x squared. X squared, I get 2x by 2 is 4x. The minus 2 I take down, that's a minus 2 times x. Now 1 again from that is minus 3, but I have to multiply by 3, so it's 3 times that, so it's, let's say, or minus 6. So it's 3x squared plus 4x. That minus 2 is by 3, so it's minus 6x to the minus 3. 3x squared plus 4x to the 1, or 4x, minus 6x to the minus 3. So really, all we're saying here is that it doesn't matter what you're given. If you're given y is equal to x to the minus 2, dy dx is minus 2 times x to the minus 3. If you're given y is equal to x to the half, you look it up again and you say, well, it's just a number n, so I'm going to change it. So dy dx is a half x to the half minus 1, and a half minus 1 is minus a half. So dy dx would be a half times x to the minus a half. So really have very little respect, it's just use the formula as it's given. If somebody says y is equal to x to the 13.3 dy dx, you say, well, there's only one formula here. If it's x to the something, I just take down the something, and reduce it by that number. If somebody said y is equal to x to the pi, you say dy dx is pi times x to the pi minus 1. Just plug it in. So if you see a number you're not familiar with, if it's x to the sine theta or anything, it doesn't matter. Just take it down, sine theta times x to the sine theta minus 1. If y is equal to x to the elephant, dy dx is elephant times x to the elephant minus 1. That's it. So we have that formula and it seems to be working for us. So let's see, does it work for other examples? Differentiate 4x to the half plus 2x to the 3 over 2. Now, we mightn't have liked that question because we said that's a bit more awkward than before. But really, it's not really. It's y is equal to 4 times. What happens to x to the half? The half comes down and it becomes a half minus 1. What happens to the x to the 3 over 2? The 3 over 2 comes down. X to the 3 over 2 minus 1. So y is equal to 4 times half is 2. Half minus 1 is minus a half. 2 times 3 over 2 is 3. 3 over 2 minus 1 is a half. And that's what that is. I was using dy dx there, sorry. That should have been dy dx. It should have been f dash x. So that was the original y, or the original f of x, and these were the f dash x's, or the dy dx. Now, we move now to another question, and we say differentiate 1 plus 3x by 4 minus x squared with respect to x. And we look at the tables, tools, and we say, that's not fitting that. It's not just x to the power of something, it's something by something. So it's an expression by another expression. So we see here that if it's u by v, an expression by something else, well then it's u dv dx plus v du dx. So effectively, the first bit I have to call u and the second bit I have to call v. So what I do now is I say, I'm going to call that u and I'm going to call that v. Because it's not the standard, it's one thing by another. So I'm going to say let u be 1 plus 3x and v be 4 minus x squared. So then y is equal to u by v. Now the formula says I've got to get dv dx and du dx and u and v. So what I do now is I go into a sort of a quiet zone and I say, okay, I've decided that u is equal to 1 plus 3x. I better write that down here. And that v is equal to 4 minus x squared. But I'm also looking for du dx and dv dx. So it's saying, what is du dx? How does u change with respect to x? Well, if this was y is equal to 1 plus 3x, then dy dx I'd be well used to, because it's a y on this side, the 1 doesn't change, the 3x becomes 3. But there's no reason why I have to use y. I could use u instead. So if dy dx is 3, well then, if this was u, du dx would be 3. So I'd say 1 doesn't change, 3x with respect to x is just 3, so that's du dx. And I use the same approach for v. V is equal to 4 minus x squared. So dv dx will be, I forget the 4, x squared will become 2x, minus x squared will be minus 2x, dv dx is minus 2x. So that's really how, and I have those written down now so I know what those answers are, because I'm going to need those when I plug them into my answer. I've got a dv dx, which is great. I've got a du dx, which is great. I've got a v and I've got a u. Looks like I should be able to calculate dy dx. So I copy those. If I go to another page, I'm going to copy those over. So here they are again on the next page. And I'm going to now get dy dx. Now I just write it down. Dy dx is u dv dx. That's just copying from the log tables. And I'm going to get marks for doing that because the examiner will know that I've picked up the right one or whatever, and I'm going to use it. So dy dx is, and now I go into zone down mode. I say dy dx is u. U is here, 1 plus 3x. dv dx is here, it's minus 2x, plus v, 4 minus x squared, that's that, and du dx is 3. So now I can come up for air. I've written down what that is. It's now just doing the algebra. So 1 times minus 2x is minus 2x. 3x by minus 2x, 3 by minus 2 is minus 6. X by x is x squared. 4 by 3 is 12. Minus x squared by 3 is minus 3x squared. So that's that. Now I can see that there's a term in x squared of minus 6x squared and minus 3x squared. So they together become minus 9x squared. I've got a minus 2x and a plus 12. So I've got minus 9x squared minus 2x plus 12. And that's the answer. I found the change, the rate of change, the dy dx of this whole formula here using this trick that I had here, the second one in my toolbox, the product rule, and that's in the tables. Now just to show that that was right, I'll just go through the, could you have done that another way? Well, maybe you could have if they didn't ask you to use the product rule. But you could have said that y is equal to 1 plus 3x 4 minus x squared. And you said, I'm just going to multiply those out. So the first by the first is y is equal to 1 by 4 is 4. 1 by the last is minus x squared. 3x by that is 12x. And 3x by minus x squared is minus 3x squared. So I've got a 4, I've got a minus x squared, I've got a 12x and whatever. So I could join those again and say, well, I've got, looks like I've got 1 by 4, that's minus, that's plus, and that's minus. Great. So adding those together, I get 4 minus 4x squared plus 12x. Okay? Now, what's dy dx? Let's see, 1 plus 3x. Yes, that should be right. I'm just checking that again. Sorry, 1 by 4 is 4. That's minus x squared. 3x by 4 is 12x. 3x by that is minus 3x cubed. Sorry, that's what the area was. 3x by that is 3x cubed. So let's just look at that. I've got 4 minus x squared plus 12x minus 3x cubed. If I differentiate this, I'll tidy that up a bit. Y is equal to minus 3x cubed minus x squared. This is really going well. Yeah. So maybe we wind back again and I'll do that calculation again. We've solved it on the product rule and we found that the answer is minus 9x squared minus 2x plus 12. Okay, so I'm going to multiply it out again just to show that the answer is correct. 1 plus 3x by 4 minus x squared. I'll use the FOIL method and do it slowly this time. 1 by 4 is 4. Outside, minus x squared. Inside, plus 12x. And the last is minus 3x cubed. Okay? So now I have y is equal to minus 3x cubed minus x squared plus 12x plus 4. dy dx, if you were to do this using the first method, you'd say all of them are x to the powers of. So x cubed, I take down the 3. 3 times 3 would be 9. It would make that a minus 9x squared. The x squared would come down and I get minus 2x. And then I'd get the 12x would become 12 and the 4 would go away. So that minus 9x squared minus 2x plus 12 will be the same as this one here. So what does that mean? It means that if you're given this question in the exam where you have one thing by another, you can choose to multiply them out and differentiate, but if it says use the product rule, you use the product rule and you get the same answer. Okay, we move on. The next question in calculus is this one, and they say differentiate y is equal to 3x over 2x plus 3. Here you've got something over something else. So you look up your toolbox and you say, okay, well, it's not just x to the power, and it's not one thing by another. What else have I got? Well, I've got this one here, something over something else. Oh, that's very handy. So that's probably it, u over v. So I'm going to say that the top bit is going to be called u and the bottom bit is going to be called v. So the top bit is 3x and the bottom bit is 2x plus 3. So again, I go into a zone and I say, okay, if I'm saying u is 3x, I better write that down. If I'm saying v is 2x plus 3, I better write that down. But for this equation, I'm going to need du dx, dv dx, and v squared. So I'll need to get a du dx and a dv dx. So if u is 3x, what's du dx? Well, if y was 3x, dy dx would be 3. So if u is 3x, du dx will be 3 because it's the change of this variable with respect to that. So du dx will be 3. If it's 3x, it becomes 3. If it's 2x here, it becomes 2. And the 3, we get nothing because it's a constant. So du dx is 3 and dv dx is 2. So what I have now is I've done my preparatory work. I figured out, here we go, we've got u and v and the relationships. And we're now asking to differentiate this. So I'm going to use the formula. It says if it's u over v, dy dx is all of this. So I'm just going to copy that out into my exam paper. And here I've copied it out. dy dx is v du dx minus u dv dx over v squared. And I'll get marks for that because I'll have identified the right one and the examiner will be with me. Now, I now go into the zone and I say, okay, I'm going to swap these things in. dy dx is v. V is 2x plus 3 times du dx. That's 3 minus u is 3x, dv dx 2, all over v squared. So here I have 2x plus 3 minus 3x times 2 over 2x plus 3 squared. I can come up for air now, and I can sort of say, okay, this is just algebra, so just multiply the 3, and 3 by 2x is 6x, 3 by 3 is 9, 2 by 3 is 6x, and then the minus, okay? And 2x plus 3 on the bottom squared. That 6x and that 6x cancel, so that's my answer. And what I have is a lovely equation. I've got dy dx is 9 over 2x plus 3 squared. And that's it. This one here I'll just show you. It's just a way in case it can come up. You can do this in different ways, but just to show that there is possible to, it's called the chain rule, and it's the last of the tools that are there. And it shows that when f of x is u times v of something, then f of dash x is du dv by dv dx. Now let me explain this for the moment. Here's something where it says differentiate y is equal to 5 minus x squared cubed. And you say, that's a bit tricky. How would I do that? really y is equal to 5 minus x squared by 5 minus x squared by 5 minus x squared. And you could multiply all of that out and get a very long equation and solve it. So you can do it that way, and that's fine. Just as you would if this was 5 minus x squared squared, you could just multiply it out. But there's another way of doing it. You can say, I don't like this thing in the middle. So if you don't like something, you generally substitute it with either u or v. In this case, I'm going to substitute it with u. I'm going to say let u be the thing I don't like, 5 minus x squared. So now the question becomes y is equal to u cubed. And that looks a lot neater, really, than y is equal to all of that. Well, if y is equal to u cubed and u is equal to 5 minus x squared, what I'm going to get here is I'm going to say if y is u cubed, what's dy du? Well, if y was x cubed, it would be 3x squared. If y is u cubed, it's 3u squared. So that's dy du. If u is equal to 5 minus x squared, what's du dx? Well, 5 doesn't change. X squared will become 2x and the minus there. And that's that there. So I'm now sort of ready to use this equation. I've decided that u was equal to this, y is equal to u cubed then, and I've written out all these handy notes for myself later that I've copied here. So what does the formula say? It says instead of getting dy dx, you get du dx by dv dx. That's how you do it. So basically what you say here is you take, so the answer is you get dy dx is dy du by du dx. This here is dy. You multiply it by du dx. So you'll see here that those two du's cancel. So dy dx is dy du by du dx. So dy dx is 3u squared times, so dy dx is dy du is 3u squared times du dx is minus 2x. We're nearly there, but I can't leave a u in the answer. I've got to change that back to an x, and u is equal to 5 minus x squared. So the answer dy dx is 3 times u, which is 5 minus x squared by minus 2x. So it's just a way of doing it. If you find something that you don't like, make it equal to a u or a v and then substitute it later. So that's how you solve it. Just in terms of the differentiation rules, when you're printing out that note there, that should read dy dv on the bottom there, dy d or dy d instead of, so that they cancel. They should have a dy dx in the end. Okay. And that's calculus. We might try a question on that for the moment as well, and just see how it comes up. And we might also link it to the various other questions that have come up. But just to start with a question here. This is a question, I'm only taking questions from the most recent years in that, but basically differentiate the function 4x cubed minus 3x squared minus x plus x minus 7. So you might just give that a go for the moment. F of x is equal to 4x cubed minus 3x squared plus x minus 7. So just give that a go for a moment, and that's how you would do that. Okay, we'll give this a go. We can look at this and we can look up the formula for it, and we can see that's one of our standard questions where we can use the formula sheet that we have. We can say that's our first formula that we use. So it is the y equals x to the n that we can use. So dy dx is n times x to the n minus 1. So let's start. The x cubed would become 3x squared with the 4 in front of it as a multiplier. The x squared will become 2x with the minus 3 in front of it. The x would become just 1 and the 7 would disappear. So we end up with 12x squared minus 6x plus 1. And that's the question. Differentiate the function, and there's marks for that. Find the slope of the tangent to the graph, it's the same function, at the point 1 minus 5. Remember that slope is another word for dy dx, is another word for m, or f dash x. And it says, find the slope of the tangent to the graph. Well, it's the same graph, so to find the slope, we find dy dx. So dy dx is 12x squared minus 6x plus 1. Find when at the point 1 minus 5. Remember that every point is x, y. X is always first. So in other words, what's the value of this when x is equal to 1? All you have to do here is put in 1 wherever there's an x. So it's 12, 1 squared, minus 6 times 1 plus 1. So 12 minus 6 plus 1, which is 7. And that's how the marks just, and then find the equation of the tangent. Well, this is more a line question than a calculus question. But if you have the slope of 7, and you know a point on the graph, so you know x1, y1, you can work out what the equation of the line is. I think the formula is y minus y1 is equal to m into x minus x1, or something like that. If you know that x1, y1 is 1 minus 5, and you know that m is 7, you can plug in all your answers there. So that's how the marks come, and that's how calculus links up with the line and the functions and graphs that we did earlier. Okay. So we take a break now for a minute, and I'm going to start on distance, speed, and acceleration. Just bear with me a second while I get a ball. So, thank you for being with me. They were the calculus questions. Now, there's a lot of calculus questions where they just give you a formula, and you're asked to use it to find either using algebra or something. But there's always a calculus question with lots of marks going for practical calculus questions. And while they look and they might sound difficult at first, they're really all the same. So what I'm going to do now is I'm going to turn off my background. That's no longer the Griffith College background, and I'm going to just show you a bare wall. I'm going to turn up here to this. And that's just me in a room with a blank wall behind me, because I wanted to show you something in calculus like this. Calculus is really useful. I said it tells you something like the max, or the min, or the best, or the worst, or the most effective. But when they were designing maths back in 2015, the maths course for the Leaving Certificate, they called it project maths. And they were very keen that people would be able to solve real life problems in the world. So one of those that comes up a lot is about speed and acceleration and distance. How fast do people travel? What's their acceleration? What's the highest point? And And very often here I have a ball here, and basically they talk about throwing something up in the air. And they say, what is the max height that that ball reaches? How do we know? What's its speed at the max point? When does it hit the ground? At what time? And all that. And a lot of these questions seem quite practical, and they're a bit difficult maybe to join the calculus at the first time. But we're going to go through these, and they're all the same. And I'm going to show you that you're using these terms all the time anyway, and you really can deserve to understand it, and you probably do already. So I'm going to just look at the ball and ask a question or two. In calculus, they talk about throwing a ball in the air, reaching a max height, and then falling down. But there are three things to do with distance that are important. The first one is the distance itself between 2 points, the speed at which you move from one point to another, and the third is the acceleration. Now, if I drive from Dublin to Limerick, it might be a distance of, say, 120 or whatever miles or 200 kilometres. That's a distance. But if I do that in 2 hours, that's 100 kilometres per hour. Distance per hour. The change in distance over time. That is dy dx. It's the rate of change of distance over time. Sometimes we call it, dx dt, because t is the time. If I accelerate, let's say I'm doing 60 kilometers an hour on a road and I'm going onto the motorway, and I go from 60 to 120 on the motorway in, say, 6 seconds. Every second I go 60, 70, 80, 90, 100, etc. I'm changing the speed. And if I'm changing the speed, I'm accelerating. So the change in speed is the derivative of the speed with respect to time. That's d2y dx squared, or the distance with respect to time twice. So effectively what we have is we've got a natural thing in the world around us. One is we talk about Limerick or Cork being a certain distance from Dublin or from Limerick or from Galway. But we also talk about getting there at a certain speed. I was doing 60 kilometers per hour. So distance per time. Or I was accelerating at the rate of the change in speed per minute or something like that. So we've got y dy dx and dy dx squared, or d2y dx squared. We've got f dash, and f double dash. So basically, before we go into this question, I just want to ask you to reflect on what happens when I throw a ball in the air. If I throw a ball in the air, its distance from the ground changes from 0 up to a certain height and comes down. But there's something important about the curve of the ball in the air. At some point, it reaches the max height. Now, what happens at that max height? In terms of maybe speed. What is the speed at the max height? It starts off going fast, goes slower and slower and slower, and then it stops. So the point of the max height is actually when the speed is 0. Speed is 0, that is dy dx. Speed is 0 at the max height, we can therefore find the max height. If we know the max height and we know what happens at a certain time, we can probably find out, more about it as well. What happens when the ball hits the ground? What do we know at that point? Might be going fast or might be accelerating. But we also know that the distance above the ground is 0. So really what we're going to do is I'm going to show up an exam question, exam standard question, and then we're going to go two or three more. These are all worth 55 points, so they're quite important, but they're very easily done. And they're always the same. They're always using the same 1, 2, 3, y dy dx d2y dx squared. So what we're going to do is we're going to show these equations. I'm going to start now with an example. But think about the ball going up. When it's at max height, it's at max height when the speed, it's just run out of speed and it falls. Okay? So forgive me now, I'm going to leave you on the main screen. I'm going to go back into my other view. And I'm going to show you the camera if I can. And hopefully you can see my hand again and my notes. So we're looking at the calculus notes. We're looking at distance, speed, and acceleration. Some people will be doing other science subjects, maybe physics in particular, and you might have seen speed being mentioned as v or velocity or s or something like that. Speed and distance, where distance is represented by s and time be represented by t, then velocity is given by v is equal to ds dt, and acceleration by this. So basically we've got v is equal to ds dt, and a is equal to d2s dt squared. So we're going to keep that as a formula. So we've got s is distance. So you might write that down in a way. We might just say, if s is distance, ds dt, distance over time, 30 kilometers an hour, speed, and d2s dt squared is acceleration. Or that's Fogg, Lewis, and Lewis-Gehry, if you're doing it as squared again. So you might also call this maybe just f of x, f dash of x, f double dash of x. Or we might be used to it as y, dy dx, and d2y dx squared. But remember, we'll probably be doing it with respect to t on the bottom for time. So we'll keep that as useful. So let's look at the question. Observation from physics. If you throw a ball in the air or something in the air, the highest point it reaches is the point when its speed is zero. That point, the speed is just run out of energy and it's just speed is zero. And it starts getting faster on the way down. So this is the exam question. A missile is fired up in the air. The height h meters of the missile above the firing position is given by this. So h is t 200 minus 5t. We're used to y and x. What? They just have h on the left hand side and t's on the right hand side. So instead of a graph being y and x, we're going to have a graph of h and t. Time will be on the bottom and h height will be on the top. But it's the same idea. Just imagine that's a y and imagine that's an x. So the basic graph is that y, the distance, is given by t 200 minus 5t. 200 minus 5t. Where t is the time in seconds from the instant the missile is fired. Find the speed of the missile after 10 seconds. The acceleration of the missile. 1 second before reaching its greatest possible height, the missile strikes a target. Find the height of the target. So there's a lot going on here. They want the speed of the missile, the acceleration, and something about height. So let's look at the formulas that we have. Well, we said that these questions are the same. So there's a distance bit, there's a speed, and acceleration. So let's see if we can look at distance, speed. Distance might be the same as height, it's just height above the ground, so same as distance. So I'm going to start with the equation h is equal to t 200 minus 5t. Now we could imagine that that's something like y is equal to u by v with two things there. But I think we might be able to just simply multiply it in. So we might just say h is equal to 200t minus 5t squared. So that's the basic equation for height. Now we had this tool, I suppose, or toolbox that says distance, speed, and acceleration. So if that's the height or the distance, let's look at the speed. dh dt. Let's differentiate this once. Differentiating, if that was 200x, it would be 200. If it's 200t, it would be 200. 5t squared, we take the 2 down. So 2 times 5 is 10. And the t would be left on its own, just 10t. So that's speed. And now let's go for acceleration. Let's do it again. dt squared Differentiating 200, nothing. Differentiating 10t would be just 10, and minus would be just a minus beforehand. So we now have the three answers that we need. We have the height, the speed, and the acceleration ready to use in this question. So what were we asked to do? Find the speed of the missile after 10 seconds. Okay, well, we can start by saying, what's the speed of the missile? Well, the speed is the rate of change in distance, so it's dh dt. That's the original equation there. And dh dt we got as 200 minus 10t. So we just took down the 2 squared and we took down the other 200 minus 10t. But the question actually wanted to know, what is the speed after 10 seconds? So it's not just the general equation for the speed, but the speed when t is equal to 10. Well, when t is equal to 10, we can put it in here. So we say it's 200 minus 10t, but t is equal to 10, so it's 200 minus 10 times 10. 200 minus 100, it's 100 meters per second. So we've got the first answer for this question. And we said the speed of the missile after 10 seconds is 100. We picked up an awful lot of the marks at this stage, particularly if we decided to give them this information. So that's the first thing. The next question they wanted to know was, find the acceleration of the missile in general. So the acceleration of the missile was to take the speed equation and differentiate it. So differentiating 200 gives you nothing, and minus 10t gives you minus 10. So that's the answer for that, as we had here, minus 10. Now, the next question was, 1 second before reaching its greatest height, greatest possible height, the missile strikes the target. Find the height of that target. Now, how do we find the greatest possible height? Remember what we said was the ball runs up and falls down, up and down. The greatest possible height is when the speed was 0. So we've got to find out when is the speed 0. To get that, we'll have to use the speed equation. So the speed equation was 200 minus 10t. When is that equal to 0? When is 200 minus 10t equal to 0? Well, we don't like the 10t on this side, we move it to the other side. 200 equals 10t. Divide by 10. T is equal to 20, or 20 equals t. T is equal to 20 seconds. So what we're saying is that the greatest possible height was when speed was 0. That was the one thing we remembered from physics. We said that if it goes up here, the speed at the top is 0 and falls down. So that's 20 seconds. What was the question? 1 second before reaching its greatest possible height. Well, 1 second before 20 is 19. So really we're saying, find the height of the target when t is equal to 19. So now we're asking, the last part is just find the greatest possible height. Well, if they're looking for height, they want us to use the height equation, not the speed or not the acceleration. They're saying, what's the height when t is equal to 19? So here we have the height. So that was when we found out it was 20 seconds, and we know that it's 19 seconds is the best point we're looking for. The general equation for the height was h was equal to 200t minus 5t squared. But we want to know when t is equal to 19. So all we do is we plug 19 into the equation. 19 times this, and we get 1995 meters. And these are the questions that the examiners particularly like. Because when you think about it, when you talk about that equation, even in general to at home or parents or whatever, it sounds like it's pretty impressive that here you are, you're firing missiles in the air, you're finding acceleration and the speed, and you're just using the same 3 steps in calculus all the time. The height, speed, and the acceleration. And you've got to figure out what equation are they looking for? Are they looking for it in general, or are they looking for it at a certain time? So here they say, find the speed of the missile. Okay, so it's the speed equation, this one here, after 10 seconds. So they want it when t is equal to 10. Find the acceleration of the missile. Here's the equation. They just want it in general. Find the greatest height. It's the height equation when t is 1 second before t is 90. And that's it. So that's the calculus on your course. And we're going to show you now, I'm going to take time out now, just to do 1 or 2 questions just to show you how they're done. I invite you to do them with me as we go through them. So let me just find recent exam questions on the calculus side in this way. So we just take a minute, I'll be back shortly. Okay? While I just get those. Okay? Bear with me a sec. Okay, welcome back. So this is question 8. I don't know whether it's 2019 or 2020, but they're all fairly standard. A swimmer is on the starting block at the beginning of a race. When she dives off the block until she resurfaces, the level of the swimmer relative to the water is given by the function. So I'll just write that out slightly larger. The function is hx is equal to 1 over 60 x squared minus 1 over 4x plus 3 over 5. In the function, x is the horizontal distance in meters of the swimmer from the block, naught less than x less than or equal to 12, and height is measured in, and hx is measured in meters. Okay, so we're talking about the distance from the block. Find the height of the block above the water. So a swimmer is on a starting block at the beginning of a race. When she dives off the block, she resurfaces. The level of the swimmer relative to the level of water is given by the function hx. Now these questions, by the way, are on the State Commission's exams. They'll be in your recent packs as well. These are just 2019, 2020 questions, so you'll be able to get them. So swimmers on the starting block of the case, when she resurfaces, the level of the swimmer relative to the water is given by the function. So the level of the swimmer relative to the water, the height above the water. Okay, so h is height. And x is this distance as they move across. So you can imagine the swimmer swimming in the pool as he or she, or she swims in the pool. Here's the pool, and maybe here's the block, and the swimmer sort of dives in and probably goes down and surfaces in some way like that. So as they swim in or something like that, they might be slightly deeper on the first dive than they were on the second as they go into the water. And you've got to figure out the various points on this path when she hits the water or goes under and over, etc. And that's the dive. So that's the basic question. So find the height of the block of the water. Now, remember that x is the distance from the block. So this might be, say, 25-meter pool or something like that. We might say, look, in fact, I think it said it's only a 12-meter pool. So it's quite a small pool in that sense. Okay? Basically, how far is the swimmer when she hasn't started yet? So how far is she from the block? Well, the answer to that would be probably 0, because she's nowhere from the block. She's on the block. Okay? So we start off there and we say, here's the equation for height. So let's write down the equations. We'll say height equation, hx is equal to 1 over 60 x squared minus 1 over x plus 3 over 5. So that's our height equation. I think we'll do the speed equation as well, in case we need it. We probably do. We're asked for the derivative, and we're asked later on that, find its greatest depth. Okay, great. Now, so the speed, I think, if we get x squared, we'd get 2x. So that'll be 1 over 30x. The minus a quarter will be just minus a quarter, and that'll be 0. So that'll be the speed. So that's speed, or h dash x. If we were asked for h double dash x, we may not be. We'd find it's just 1 over 30. Okay, and that's fine. Now, find the height of the block above the water. Well, really what they're saying here, find the height of the block when she hasn't moved at all. So when she hasn't moved at all, x is equal to 0. If x is equal to 0, well, that's 0, and it's 3/5. So the block is just 3/5 above the water. Show that the swimmer is on the surface of the water when she is 12 meters from the starting block. hx is equal to 1 over 60 x squared minus 1 over 4x plus 3 over 5. Show that that's equal to 0 when x is equal to 12. Show that the swimmer is on the surface when x is equal to 12. How would you do that? You have an equation for height. You're told it's distance 12, and you plug it in. What is the height at a value? So that's the height function. That's when you want to measure it. You plug in 12. So 1 over 60 by 12 squared minus 1 over 4 times 12 plus 3 over 5 equals. And you'll find that that turns out to be 0. That's 144 or something like that. So that turns out to be whatever, 2 and I'll work that out, 144 over 60. You should know that. Just use a calculator here. 2.4, so that's 2 and 2 over 5, minus this here is 3 plus 3/5. So 3/5 and 2/5 would be 1 plus, that all turns out to be 0. So that's how you prove that. Again, you've got an equation for height and you plug in a value. Find the horizontal distance in meters from the starting block to the point where the swimmer enters the water. How do you find out where the swimmer enters the water? Well, what height will the swimmer be above the water when she enters the water? The height will be 0. So, again, you've got to figure out where's the height. Well, she's not above the water, so she's just touching the water. So therefore, the equation for height is given by hx, 1 over 60, the same equation all the time. And you're saying that must equal 0. How do you solve that? Well, you might multiply it by 60 to make it easier. So that would give you x squared minus 15x multiplied by 60. And multiply that by 60, I think would give you 36. And then you've got an equation, like a quadratic equation. How would you find the roots of that quadratic equation? You could do it by sort of factors if you wanted, or you could do it by the minus b. The 36, I think 12 and 3 might do it, because that would give you the 15. So basically at 3 meters or at 12 meters, this person is hitting the water. And I don't think the swimmer could jump 12 meters. It's probably just 3. So the first time she hits the water, where she enters the water, is at 3 meters. The next part is find the derivative, which we did. Find h dash of this. 1 over 60x squared minus 1 over 4x plus 3 over 5. So you find the derivative. So for x squared you get 2x, so that's x over 30 minus 1 over 4. And use that to find the horizontal and distance from the starting point at which the swimmer reaches her greatest depth. Now this is where the physics comes in again. Here's the swimmer jumping into the swimming pool. Okay? Sorry, here's the pool. And the swimmer goes in something like this. How do you find that greatest depth? Well, what do we know about the curve at that point? At the greatest depth, the person is no longer going down or coming up, the person is horizontal. So we can say that the rate of change, dh dx, is 0. So that's how we find that. So really we've got to find out when is dh dx equal to 0. As we can see the graph, we can see that's the minimum point. We can see that's the way the swimmer is going to go. So here we have, I think we've got a formula for dh d. 1 over 30x. So when is that equal to 0? So it's not nice, it's an equation. We could say x over 30 is 1 over 4. I don't like the 30. I'm going to multiply both sides by 30. So that gives me x, they cancel, is 30 over 4, which is 7.5. So what we've done in that short period of time is we've done the whole question, I suppose, on the swimmer, and we've seen how it works. Hence find the greatest depth. So what I'd like to do now is to do another question. I think this might be 2019 or 2020. And we're going to talk about Camogie goalkeeper, this question. And it's very similar to the first one we did. But just again, to get used to these. And remember that when you're doing these questions, you can try any question you can, but all of the answers to every single Leaving Cert question is on the Examination State Commission site. So you can see how it's done and multiple ways in which it can be done sometimes. So we're going to look now at the Camogie goalkeeper. He or she, it's Camogie I suppose, on a level playing pitch, hit a ball straight up in the air. So hit the ball in the air, probably maybe didn't do it from the ground. The path the ball travelled can be modelled by the function minus 4t squared plus 16t plus 1. So we've got a function here now. The path the ball travelled can be modelled, where t is the time in seconds from when the ball is hit, and ft was the height of the ball. So it looks like we've got height and we've got time. So we write that equation down again and we say f of t is equal to minus 4t squared plus 16t plus 1. And that's our height equation. At what height was the ball hit by the goalkeeper? Now, really I think we're starting with the goalkeeper hitting the ball. So after that it goes up a certain height. But the goalkeeper hit the ball at time 0. So really what we're saying is find the value of the height at the point 0. So when t is 0, we get 0 plus 0 plus 1. So it looks like 1 meter, was about the height when the Camogie goalkeeper hit the ball. And that would make sense. So at what height was the ball when it was hit by the goalkeeper? Complete the table below to show the height of the ball at various intervals during the first 4 seconds. So here we have, what is f of 0? We got 1. What's f of 1, f of 2, f of 3, and f of 4? So again, this is back to this morning. Can you plot values in a function? You write down the function, you put in when it's 0, when it's 1, when it's 2, when it's 3. Sometimes they give you a number, or they've done one here at 2.5, which is nice. So sorry, it's not up to 4 seconds. You've got to do all the gaps as well. Sorry. So let's take 2.5. So minus 4 by 2.5 squared plus 16 times 2.5 plus 1. So 2.5 by 2.5 I think is 6.25 by minus 4 plus 16 by 2.5 plus 1. Again, this is a calculator. You do your best, you try to get them right, you try to take as much time as you can. But 4 by that would be minus 25, I think. That would be 16 by that would be 3240, I think, plus 1. So that I think would turn out to be about 16. And it is. Great. But you get each of them there. For 1, you say minus 4 times 1 squared plus 16 times 1 plus 1. So that would be 13, I think. And you fill out the numbers as you're asked to. And then you might draw it as well if they ask you to draw it. So that's the first 4 seconds. So remember that you've got marks for plugging in the equation here for just when t is 0. Marks for finding out the other values as well. On the grid below, show a graph of the ball. So let's say it goes something like that, I don't know. Some other graph like that. So you just plug in the numbers. Whatever the numbers turned out to be, you fit it and you curve it like we did earlier this morning. Use your graph to estimate the length of time the ball was in the air from the time it was hit until it landed on the ground. Now, this is probably not the right graph, but if it was, you could say, if that's 1, 2, 3, 4, 5, that's about 6. And you might say slightly after 6, it hit the ground. But if we had the proper numbers done and we had gone through the whole step, we'd be able to see maybe it happens a bit earlier than that or whatever. So use your graph to estimate. You don't have to do any calculations. You just look at what you've drawn and you sort of predict where it's going to come in. And you get as close as you can by eye. Show your work on the graph above. The length of time the ball was in the air from the time it was hit until it landed on the ground. Now, think about this. The camogie player hits the ball up in the air from 1 meter until it lands on the ground. It's the ground, it's the very base. It's gone. Now, we want to find out when does it hit the ground. What equations do we have? No, we don't have too many, but we have one, I think, for height. And let's see if we can resurrect that wherever that was. I think we'll go back to the equation. I'll write it out again. The equation they gave for it was f of t minus 4t squared plus 16t plus 1. So that is the equation for height. The general equation for height for every single value of t. But we're interested in a particular time. We're interested when the ball hits the ground. So when the ball hits the ground, the height is 0. So really what we're saying is we want minus 4t squared plus 16t plus 1 to be equal to 0. And that's what we've got to solve. Or we could say 4t squared minus 16t minus 1 equals 0. When is t equal to, when does that work? Well, I don't think I can spot that too easily with factors. So I'm going to say that's ax squared plus bx plus c equals 0. I'm going to say the a value is 4. The b coefficient is minus 16 and the c is minus 1. So I'm going to say the time when that's equal to 0 is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So the minus b will give me 16 plus or minus the square root of 16 squared, well plus 16 squared, minus 4 times 1, 4 times 4 by minus c over 2a, which is 8, I think. It's a bit of work in that. I've written down the formula, I got marks for that. I transcribed the numbers in, I got marks for that. And now it's just using a calculator. So 16 squared I think is 256 plus another 16 is 272 or something like that. So I get something like this on a calculator. 16 plus or minus the square root of 272 over 8. I'll get the square root of 272 now if I can. Which is 16 plus or minus 16.5 or something like that over 8. And it looks like I should be able to calculate that. I don't think I'll go with the minus, I might go with the plus. 4.06 seconds or something like that. So the length of the time the ball was in the air, the length of the time was landed on the ground, I got 4.06 seconds. Show your work. The length of the time the ball was 10 meters or more above the ground. Show your work on the graph paper. Now, if you want to do that by graph or by time, when was it above 10 meters? You'd look at it here and look at it here and say that was about 1.7 seconds and that was about 5 point something seconds, and show your calculations there. Find the derivative of the equation, which we've just done, and use your answer to find the speed of the ball when it had been in the air for 4 seconds. Remember, take them all the same. There's the height equation. Fine. What are they looking for? Use your answer to find the speed. Speed is not height. You must get the differentiation. So if height is minus 4t squared plus 16t plus 1, speed must be first derivative minus 8t plus 16. Take the t squared out. So speed is that. That's the general equation for speed, but find the speed when t was equal to 4. When t was equal to 4, you've got minus 32 plus that. So the speed is coming down at minus. Don't worry about the minus, that just tells you it's coming down from the sky or something like that. So that's it. So when t is equal to 4, it's minus 32 plus 16, which is minus 16 meters per second. It's coming down very fast. Use your answer to find the value for t for which the ball was descending and travelling at a speed of 8 meters per second. Well, again, you've got a speed, and it says when was the speed equal to 8? Well, the speed was equal to 8 when minus 8t was equal to minus 8, when 8t was equal to 8, and t was equal to 1. So all of these questions are fairly similar. They give you the opportunity to say the first one is height, then speed, sometimes acceleration as well. So what have we done? Well, let's go back. We've covered calculus, we've looked at the various topics in it, and we've covered the questions that can come up in the exam. So I'm going to stop sharing for a minute. I'm going to go back to maybe some background as well, so I'm no longer just against a black wall, but I'm coming to you from Griffith College. And I'd like to thank you. It's 10 to 1, so we're finishing slightly early. But thank you very much. I look forward to starting again at 2 o'clock. If you have any questions, send them to schools@griffith.ie. Again, I'll just briefly show you where the notes are again. So just so the notes, you can go in there. I'll just go to the basic screen. So there are the notes. You'll find them on griffith.ie, www.griffith.ie. I'll go back if I can and say, that brings you into the, we go back, and again. So you start with Griffith College, griffith.ie. You come down to the maths resources. The maths resources, you go down to view them. And viewing them, you say, where are my notes for today? Thursday revision booklet, and you can print those out. So just after lunch, then I'm going to be moving on with the topics, and I'm going to take a topic on trigonometry, and I'll do complex numbers as well in the afternoon. So you might get a chance to print them out or to have them by your side, so you don't have to take down too many notes. So thank you again. Thank you for your time today. I look forward to seeing many of you back at 2 o'clock and inviting new people who are coming in as well at that stage. So slán go forward, with Tanavas the good law, and make sure you get out a bit of fresh air, take a break, clear the head, and thank you again.